Hello everyone and welcome to the second video in this series, which is Introduction to Differential Calculus. And today I'm going to show you how to use the first principle method to take the derivative of a function. Trust me, it's not difficult. This is what you can do, and if you follow me closely, you'll definitely understand how this works. So how do we do this? All right, the first principle method has a formula, and that formula is, here we have f prime of x is equal to the limit as h approaches 0, and we've got here f x plus h minus f of x all over h. Well, this is the formula for finding the derivative of a function using the first principle method. Well, I need you to understand certain term right here. Here we have f prime of x. So f prime of x is the derivative of a function. Okay, suppose you have something like y is equal to x. So you have to say dy over dx. Okay, so the derivative of this function is equal to dy over dx, right? Now, for this one right here, if you have a function like f of x, okay, so the derivative of f of x is simply f prime of x. So that is what it means. So sometimes your lecturer might give you a function like y is equal to, let's say, the root of x, and ask you to find the derivative using first principle method. It's just going to be, you just say let y, or let y, yeah, equal to f prime of x. Okay, so it's just the same thing. Or you can say let f prime of x be equal to y. It's just the same thing. You can now go ahead and say dy over dx, something like that, and continue with your solution. So right here, we're going to I'm going to show you how this works. It's kind of different from the general method, where we say we multiply by the power and subtract 1 from the power. In case you've not watched my video, I'll leave the link in the description so that you can watch it and understand how it works. Now, what's up with this first principle method of differentiation? So suppose you have a function like, let's say you have y, okay, or let's say I will say f of x. Suppose you have something like f of x is equal to 2x squared. Okay, so when you have to find this, use it, or to get the derivative using first principle method, it's going to be quite different from the power rule or from the general method. If we use the general method right now, it's going to be 2 times 2. That gives you a 4. And then here you have 4x. You subtract 1 from the power. And the derivative of 2x squared using the general method will give you 4x. All right. But in this case, it's not so. So I'm going to show you what to do right here. So we say f prime of x. Remember that f prime of x refers to the derivative, okay? Derivative of f of x. So if f of x is 2x squared, then f prime of x is the derivative. So this is equal to the limit as h approaches 0. And now what's going to happen right here is that wherever you see x, okay, let me write it up here. So we say that f of x is equal to 2x squared. So wherever you see x, you put x plus h. I say that again. Wherever you see x, you put x plus h. Okay? And this 2, we substitute it right here for f. Okay? So wherever you see x, you put x plus h. While this f of x here carries the entire function. The function is 2x squared. So in this function, wherever you see x, you put x plus h. This the number in front of the x goes to the f. Suppose let's say our function were x squared. The number in front of the x is 1. So this is just going to be x plus h, because any number multiplied by 1 is still the same. So we put an x plus h for x. And one other thing you need to know is that if your x is squared, your x plus h will also be squared. If your x is in surd form like this, your x plus h will also be in surd form. Do not forget, if your 1 or if your x is to the power of 3, your x plus h will also be raised to the power of 3. Don't forget that, it's really very important. Now let's proceed. I'm going to put my 2 for f, hence we have 2. In this case, we say multiplied by x plus h all squared. Remember, our x has a square, so we also have to square our x plus h, minus, open a bracket here. This is f of x. The f of x is our function, which is 2x squared. We put all of that in our bracket. We say 2x squared all over h. Don't forget this h. So right now, remember, in limits of functions, you can substitute a 0 for h, but it's going to be wrong at this moment, because if you put 0 here to evaluate the limit, you're going to get an indeterminate function or an indeterminate form of this expression. It's not nice for you to be getting over 0 or 0 as your answer. It's not really right. So you have to simplify this to its lowest term before you substitute. That's how it works. But if you, okay, as long as the h is down here, you always get a 0. So we don't want that to happen. We want to simplify it in a way that we'll get real solutions. And that's just how it is. So I will say my f prime of x is equal to the limit as h approaches 0. Now, before I distribute these two across everything in the bracket, I have to expand the bracket first. So here we have a 2. If you have x plus h squared, it means that x plus h is multiplying itself 2 times. So this is going to be x plus h and x plus h. So let's do that. X plus h multiplied by x plus h minus 2x squared all over h. Now let's proceed. Here we have f prime of x is equal to the limit as h approaches 0. Now, before I distribute it 2, I have to multiply out this bracket. We have our 2 outside. So x times x, okay, x times x will give you x squared. Okay, we follow it this way. So the x multiplies the h, and now the h multiplies the x, and also multiplies the h. So here we say x times x will give you x squared. Now x times h will give you xh. Next up, h times x. It does not matter the order since multiplication is commutative. H times x will give you xh, and then h times h will give you h squared. We close our bracket, and outside here we have negative 2x squared. I just remove the bracket, and we have all over h. All right, let me clean this part so that we can continue from here. Okay, now we can now go ahead and simplify. I would say f prime of x is equal to the limit as h approaches 0. So here we also have a bracket outside. We've got 2, and we have a 2 outside the bracket. We have x squared here. Now, x plus h are like terms. So this is 1x plus h, and this is 1x plus h. They now add together to give us 2x xh plus h squared. And outside the bracket, you've got minus 2x squared all over h. Can we substitute or evaluate the limit at this point? No, we can't evaluate the limit, so we have to keep on simplifying. Here we say f prime of x is equal to the limit as h approaches 0. Let's now multiply out. 2 times x squared will give you 2x squared. 2 times 2xh will give us 4xh. And then 2 times h squared would give us plus 2h squared. And outside the bracket, you've got minus 2x squared all over h. Let's proceed. Now, if you look at this numerator here, you have 2x squared minus 2x squared. These are like terms. One is a plus, the other is a minus, so you can easily cancel them out, because 2 minus 2 give you a 0. This and this, we cancel them out. And what's now remaining? We have our f prime of x is equal to the limit as h approaches 0. And we've got 4xh plus 2h squared all over h. What do we do at this point? Well, at this moment, we are going to factor out what is common on the left and on the right. On the left, h is found, and on the right, h is also found. So we want to remove this h from this denominator. That's the idea, because you can't substitute the 0 for h. Whenever you want to evaluate the limit, you end up getting a 0 down there, which is not going to be so nice. So this is equal to the limit as h approaches 0. I'm going to factor out the h. If you factor out the h, removing h from 4xh will give you 4x remaining, plus if you remove h from 2h squared, 2 of the h are here. If you remove 1, you have 1 left. So this now becomes 2h, okay, all over h. If you multiply the h by what's in the bracket, you get the original expression back. Now let's now divide. The h on top can cancel out with the h down here, and what will now be remaining? We have this is our limit as h approaches 0. I'm doing this step by step for slowness so that you can understand. We now have 4x plus 2h remaining. Let's now evaluate the limit, because we no longer have a h at the denominator. So this will now give us, I'm going to put a 0 for h. So wherever you see h, you simply put a 0, because we say as h approaches 0. So this will now become 4x plus 2 multiplied by 0. We've evaluated the limit, and that was why we stopped writing the limit. Now, this is equal to 4x. 2 times 0 gives you a 0. Therefore, your f prime of x is equal to 4x. Have you seen this? Okay, like I said originally, if you differentiate this function, which is 2x squared, using the general method, you're going to get a 4x. And you've seen the same, the method that we use right now gave us a 4x, which means that we are correct. So sometimes you can just use the general method to quickly run through the function to see what you get. And if your answer corresponds with the first principle method, it means that you're correct. So thank you for watching this video. In my next video, I'm also going to be talking about more functions or more problems that can be solved using the first principle method. Thank you for being there, and see you in the next video. Bye.